delete the things, delete the terms, delete the items, delete the numbers to make something shorter or smaller. So whenever we are going to make the terms truncated, truncated means we are leaving out or we are deleting the terms, we are deleting the digits from any number, from any expression, from any function or polynomial, then this is known as a truncation error. Means process is known as truncation, and because of that truncation, truncating the terms, that is called a truncation errors. So this truncation error is inevitable or unavoidable in the process of computations. For example, we just consider the example of Taylor series expansion. So Taylor series expansion has how many terms? Infinite number of terms. So by evaluating the infinite number of terms, it is very difficult. Even if we are to evaluate the 100 terms, then it will take much of time. So unless we apply the computers, even we cannot go for this very tedious and complicated process of evaluating the terms for several number of terms which are involved in the Taylor series expansion, and therefore the truncation is allowed, and the out of the process of truncation, whatever error is occurred, whatever error is taking place, that error is known as a truncation error. So this is a kind of approximation. If we consider the 4 terms, that is a kind of approximation. If we consider the 3 terms, a kind of approximation. We consider the 10 terms, a kind of approximation. Because the n tends to infinity, and the evaluation of consideration of all terms in the expansion of the series is not possible. And then approximation has to be done. Approximation is a must to be done. And therefore, this approximation of considering the number of terms as per the suitability, as per the requirement, as per the requirement of the time is known as a truncation error. If you look at this, I just take this annotate, and I go for this. Truncation errors are defined as those errors that result from using approximation in place of an exact mathematical procedure. What we are going to make the approximation? Approximation means if we are considering the 3 terms, then that is the approximation. And the exact mathematical procedure is what? Exact means n number of terms. If we consider the n number of terms in the exact mathematical procedure, then and only then this process would be the complete and true and exact mathematical process or procedure. Therefore, this truncation error results from the terminating after a finite number of terms. Terminating means deleting. Terminating means deleting. So finite number of terms. So known as, what is name of this formula? Truncation error, or simply the truncation error. So this must be very clear. This result occurs out of an approximation, and that approximation is supposed to replace the exact mathematical procedure or formula. It's because exact is not possible to consider by us. Now take the example. Let a function fx is infinitely differentiable in an interval which includes the point x is equal to a. Then Taylor series expansion of fx about x is equal to a is given. We are assuming fx as differentiable function which can be differentiable number of times, as many times as tends to, as it is very high, that is infinity, means we can evaluate. And this is a point at which we are going to evaluate. Then the fx is equal to k is ranging from 0 to infinity, fk a x minus a to the power k upon factorial k. This has been given by the Taylor series expansion. Is it clear? This part is clear or not? This has come to Taylor series expansion. And this is the kth derivative and kth derivative at the point A. Okay. Where fxa denotes the kth derivative of fx evaluated at x is equal to a. Same thing here, or fka is equal to dkfx and dxk at x is equal to 0. So this is the kth derivative is equivalent to, not equal to, equivalent to the kth derivative of fx with respect to x, and evaluation is made at point x is equal to 0. So if the series is truncated after n terms, I already introduced this concept, if you remember. I introduced this concept n terms already in the introduction of the concept. Truncated after n terms. How many terms this expansion has? Infinite number of terms this expansion has. So we are going to truncate. We are going to truncate after n terms. N terms means n may be 2 terms, n may be 3 terms, n may be 4. Then it is equivalent to approximate fx. One is the fx, original fx. One is original fx. But when we are going to truncate the terms, this is the original. When we are going to truncate, then approximated fx. So one will be approximated fx. Approximated fx. And approximated fx means this is approximated. This is approximation. Okay. So this polynomial of degree n minus 1. So approximated fx is this one. You look at here. fnx. fnx written in terms of, in the form of polynomial. And if you remember the polynomial, writing the polynomial fnx. So fnx means k is going to begin with from 0. 0 means n minus 1. So we are considering only n terms, mean n minus 1 is the maximum. fka x minus a and this. So this is what? This is the error. The error in approximation. Just a bit. Look at here. Now you look at here. The this part you have got. Now we are going to define the error. How we are going to define the error? The error in approximation ENX is, this book has sometimes they have written very poor language. Be mindful of the printing errors as well as the poor English presentation and the error in approximating ENX. No. What should be here? The error, the sentence must be like this. Where is text? The error in approximation ENX is equal to Samatma. It should be like the error in the error we have given the symbol the error is what? The error ENX. The error ENX. Error ENX. It is okay here. It is written ENX in approximating f x is equal to, now this, do you get me?
Yes, sir.
Yes, sir.
The error is what? ENX. And how this has come? It has come in approximating fx. But here it is written the error in approximating ENX. So you may get confused whether you are approximating the function or you are approximating the error. So this point is, this language is very, very confusing. Okay. Equal to the sum of the neglected higher order terms and is often called the tail of the series. The tail of the series is what? If you look at here, ENX is equivalent to fx minus fnx. Okay. Fx is the total and fnx is, this fnx is what? This is approximated function. This is total complete function. So when we complete minus approximated, then this is the error. This is the error. This one is error. This. And this has come from where? This has come from complete. Complete minus approximated function. Complete minus approximated. Okay. It is possible sometimes to place an upper bound on the x of ENX depending on the nature of the function. This part is clear? ENX is clear?
Yes, sir.
Okay. So this is minus. We have got it. How we have got it? This is also wrong here. This sentence is also wrong. I mean, this mathematical expression. The process is okay. This is okay. This part is okay. But here you look at. This is what? As per this, this is not x. This is not x. This is what? Here this is n. Correct your book. So fn x, and in place of x, we have substituted theta. Okay, to make it, it is possible sometimes to place an upper bound of the x. Now we are interested in the upper bound of the x. If we are interested in the upper bound of the x, if the maximum value of fn x over the interval ax is known or can be estimated, then mnx is equivalent to maximum of the A ranging between x and in between there is eta, Fn eta. Here we are going to define the bound, and if you remember the earlier one, this is the maximum value of Fnx. The maximum value of Fnx. This is very important, this one, maximum value. As a upper bound, we are going to define, so here, Fnx is equal to maximum in between Fn and theta at the point theta. The equation 1.27 and equation 2.8, the worst bound on this is the error, and just look at here.
Then
the truncation error Enx is said to be of order h to the power n. Now they are replacing it by h, so h to the power n, and this is known as the order of the hn. Order of this is known as the order of the. In other words, as h tends to 0, h tends to 0, so x tends to a, then E and x tends to 0 at the same rate as Hn, h to the power n. Hence, order of Hn is equal to C H and h is less than 1, where C is a non-zero constant. How you have got C? Mnx is what? Mnx is this one. Mnx is this one. This is Mnx is Fn. This is a derivative. Fn is what? This is the nth derivative. This meeting has been upgraded by the host and now includes unlimited time. ये कैसे हो गया? राजकुमार जी, राजकुमार.
Yes, sir.
अनलिमिटेड हो गई मीटिंग ये तो.
40 में पता नहीं क्यों देखते हैं सर.
उसमें आया था कि अब तो अनलिमिटेड आप इसको चला सकते हैं.
यस सर.
हमारे में आया था कि इसको अपग्रेड करके अनलिमिटेड कर दी गई है.
यस सर.
तो आप वाले में ज्यादा फैसिलिटी है, हमारे में तो 40 में बंद हो जाता था.
यस सर.
मोबाइल पर कुछ और रहता है क्या?
मालूम नहीं सर. स्टार्टिंग में 3 घंटे 40 मिनट का बताता है, उसके बाद अब बोल रहा है कि अनलिमिटेड है.
अभी बता रहा था अनलिमिटेड हो गई है. बचा कर रखना, नहीं पैसा वैसा अकाउंट से कटिए.
नहीं सर.
So from this, this is Mnx. Mnx is the derivative, nth derivative, and nth derivative is evaluated at particular point. So this has become a constant quantity. Mnx is a constant quantity. Factorial n is a constant quantity, and therefore it is represented by a non-zero constant quantity C. Do you get me or not? So where C is a non-zero constant. The total numerical error is the summation of the truncation and round off errors. The best way to minimize round off errors is to increase the number of significant figures of the computer. It should be noted here that round off error increases due to subtractive cancellation or due to increase in the number of computations in the analysis. The truncation error can be reduced by decreasing the step size. In general, the truncation errors are decreased as the round off errors are increased in numerical differentiation. I mean to say here, they have just to make some remarks or observations on the truncation error. If you want to minimize the truncation error, then we have to minimize the number of steps in the computational process. As computational steps or computational number of computational steps increase, that much of the truncation error also increase. So model error relate to bias that can be ascribed to incomplete mathematical models. This will also depends on the make of the computer significant figure, it should be noted the round of error due to the subtractive cancellation. I'm just coming to increased due to number of significant of the computer. This point is important. The significant figures of the computers. So if you round off, then the if you round off because of the capacity of the computer, then the round off error will also take place. So truncation error plus round off errors. This will be the total error. This is the first line. The total numerical error is the summation of the truncation error and round off errors. Suppose your computer is only adjusting or accommodating only 10 digits, significant digits, then other digits will be chopped off. Other digits will be not considered, and therefore round off error will take place. So truncation error is already taking place. Truncation error is what? Only terminating the number of terms after certain number. So we are having the truncation error, we are also having the round off error due to limited capacity of the computer, and thus the total error is a sum of truncation error plus round off error. So this is okay. Model error relate to the bias, and that is can be ascribed to the incomplete mathematical models. As there are two things. One is acquired, and another is the ascribed. This term is the ascribed. Ascribed means there are two terms. One is the two terms are very important in our daily discussion parlance, as well as in the discussion, technical discussions, as we are going to. Ascribed means which is already that is known as inherent. For example, if I become the I am a king, then my son, my daughter will become the prince or princess. Do you get me? So that is the status or the title of the prince is the ascribed position, whereas acquired spelling is wrong. This acquired means whatever we work hard to get the position, to get. This is also named self-made. Have you heard? Self-made. Self-made. Acquired means we acquire it by self-working process. So this is ascribed incomplete. If you sometimes you make incomplete mathematical modeling. If you do incomplete mathematical modeling, this part is very important. I ascribed is okay. Do you get me or not? Rajkumar. Hello. Complete mathematical modeling, mathematical models. In the very beginning, if you remember, the numerical method is nothing else. It is a branch of mathematics which programs or translates the physical problem into the mathematical problem. Mathematical problem means mathematical models. To formulate the perfect mathematical modeling, incomplete, we are just making the incomplete mathematical modeling, then a bias relate to bias that can be ascribed, that will be inherent, that will be inbuilt and embedded. There will be bias. And errors also enter into the analysis due to uncertainty in physical data on which a model is based. When there is uncertainty, then modeling becomes difficult to accommodate all the elements and components of the problems which we are going to consider. Okay, example. Very popular function. The first part is expand fx. The first part is expand fx about x is equal to 0 using Taylor series. Okay. B part is truncate the series to n is equal to 6 terms. Means you will start from 0, 1, 2, 3, 4, 5. How many terms? Up to 5th order. Remaining will be deleted, truncated. Find the relative error at x is equal x upon 4 due to truncation in B. Determine the upper bound on the magnitude of the relative error at x is equal to pi by 4 and express it as percent. Okay.
9/9 factorial.
Yes, factorial and negative, so forth, so on. Now, truncation of the Taylor series n is equal to 6. So, f6x, n has become 6. This is x minus x3 upon factorial 3 plus 5 upon factorial 5. Okay. So, fifth term after the fourth term, this is first term, x2 is the second term, not written, not expansion, x3, x4, so up to fifth, and n is equal to 6 is considered here. The relative error at x is equal to x by due to truncation in B is given. You look at here, R means relative error, 6 means 6 terms are being considered. So this is written in this way. It is evaluated like this. 29, we have the upper bound on the truncation error given by this. To understand the truncation error. Now next, I don't know machine epsilon is in your course or not. I have not seen your course. You can check it. Error propagation is in course. The device can manipulate depends on its hardware configuration. Do you get this point or not? It is a device which has the limited or fixed number of significant digits which it can handle and deal with, and this depends on the its make and design, that is the hardware configuration. What they are going to explain, machine epsilon, that is epsilon m stands for machine, epsilon is the symbol, is the smallest positive number. You are very much familiar with the epsilon, very favorite quantity in mathematical analysis. Whenever we are going to define the limit, we are going to define the continuity of the function, because of without this epsilon, without delta, we are not able to define. The same epsilon is being defined in different way here. Is the smallest positive. There was also the smaller quantity, however small delta or epsilon is a quantity, however small it may be. This was our prepositions or assumptions before defining the limits, continuity, etc. Therefore, epsilon is a very popular quantity among the mathematicians. So it is defined the device can add to one which recognizing the sum of different than one. So this quantity is what? This is a smallest positive number that the device can add to one while recognizing the sum as different than one. So one has to be different quantity, quantity different than one is recognized by the computer by adding the epsilon machine. So epsilon m is determined computationally by finding the smallest positive epsilon is for which 1 plus epsilon that is not equal to 1. That is a very beautiful concept here they have given. If you want to know the quantity which is more than 1, then epsilon is a quantity here, means that is known as a machine epsilon. That was the continuity epsilon, that was the limit epsilon, but here is the machine epsilon. For instance, if a particular computing device computes this for 1 plus 10 to the power 9, but 1 for 1 plus 10 to the power 9, then we conclude that the epsilon machine ranges in between 10 to the power minus 10 and 10 to the power 9, and device in this way, in this case, would be known as a 10 significant digit device. Now we come to the error propagation. What is the error propagation? I erase this very thing. Propagation is what? Table 1.5 is this table. Okay. The errors. Okay. It is summarizing the error, but let us understand what is the anyone propagate. Propagate. Propagate means to forward the things ahead. To move the things ahead. चीजों को आगे बढ़ाना, एरर को आगे बढ़ाना. एरर कैसे आगे बढ़ती है? Like this. So errors attributed to the round of errors summarizes the errors attributed to the round of error. Summarizes the errors attributed to the round of errors. Attributed means caused by round of error. Attributed to. It is always written attributed to. I take the help of this your text. Attributed to. Attributes ahead. Okay. Then here digits fixed. In order to illustrate these errors, we consider the following numbers. A is this, B is this, small. D is this. These are A, capital B, capital C, and capital D. Now, possible types of round off errors on a finite precision computing device. Finite precision computing device means possible types of round off errors. These errors are because of the rounding off. Where we make the rounding? We make the rounding decimal places after certain decimal places that is known as significant digits. 1 place, 2 place, 3 place, 4 place. So we round off. We are interested in 3 decimal places. So 4th, 5th, all these terms will be rounded off. Mute all. Rajkumar ji, mute all.
म्यूट करो.
Mute all.
यहाँ तो हो रहा है सुभाष कहीं.
हाँ?
सुभाष कोई है.
Interested in 25 significant digits, but I cannot allow the 25 significant digits. I allow only the 12 significant digits. Then it has precision, but finite precision. Precision means if it allows 25, I want 25, I intend 25, and it allows 25, this is the high precision computing. And if it is not, it allows limited, then it is finite precision computing device. So possible types of round off errors on a finite precision device. Okay, then what happens? Negligible addition. You look at here, error, negligible addition. What? When two number of notable different magnitudes are added or subtracted, then the result rounds to the largest number. If two numbers are notable numbers, different magnitudes, they are being added or subtracted, then the result rounds to the largest number. Okay, the number which is largest, that will be, then the result, then the rounding take place according to the largest number, not a smaller number. Creeping round off. Repeated rounding to k significant digits will result in accumulation of errors. Repeated, this is creeping round off. Repeated rounding to k significant digits. K is important here in accumulation of errors. Now third is error magnification. Occurs when an erroneous number is multiplied or divided by a number of large or small magnitude. Error magnification means error will increase. Magnification means exceeding or increasing. This means when if we involve in our computing process any erroneous number, something is wrong, then either we multiply or either we divide it by a large or small magnitudes, then error will be magnified. That is known as a error magnification. Subtractive cancellation. Subtractive cancellation, I just remove this, lies in significant digits well beyond the device's capacity to record. The subtractive cancellation means this will cancel after subtraction due to subtraction of two nearly equal numbers, where the difference lies in significant digits well beyond the device's capacity. This will depend on the capacity of the device, means computing device. If it is finite precision, then this will depend on the cancellation of digits. Only the significant digits will be taken care of or will be taken into consideration. Now these are the tables. They have made A minus C and B plus D. This is the multiplication. This is the division. This is A minus B. And here they rounded to 4 significant digits as per the finite capacity of the computer. So this is the capital one. Error estimation, is it in your course? Error estimation. So today I will check my course which is available on the numerical analysis group. So if you have any doubts, आपको कोई चीज पूछना हो तो पूछ सकते हैं, नहीं तो today I wind up my lecture because next lecture is due 11.